Identities part 2. What we're going to be spending most of our time with here is practicing how to simplify using identities. Okay, but before we do that, I need to give you one more list of identities. These are called the cofunction relationships. And we're finally going to understand why we named the functions the way that we did. Why do we have sine and cosine? Why do we have secant and cosecant? Why do we have tangent and cotangent? Why those names? These cofunction relationships go back to thinking about right triangles. Okay, so I'm going to go ahead and just sketch a picture over to the side real quick. Just want to make sure that I got a right triangle. All right, let's go ahead and make that theta as well, just for the sake of reference. All right, so first, the sine of theta, I'm going to go ahead and just write down what this equals. The sine of theta is going to be equal to the cosine of 90 minus theta. Okay, I'll do this in terms of degrees just for the sake of doing it, but it all could be done in radians. Okay, all this would work for radians. All right, so let's think about the picture here. A triangle adds up to 180 degrees, right? A triangle is 180 degrees, and 90 of those degrees are used up right here in this corner. That means that these two angles here are going to be complements, that they would add up to 90 degrees. And that's what we have going on over here. Whatever theta is that we put into the sine, this part right here is the complement that goes along with it. It's the complement. So it would be this angle that would be located there. Now remember that when we did this with right triangles, we talked about the sine of theta being equal to the opposite divided by the hypotenuse. Okay, so the sine of theta, the opposite of that would be this side over here, divided by the hypotenuse. Okay, so remember those, it's going to be this vertical divided by the hypotenuse. Now, if I do the cosine of the complement angle, which is over here, that definition is the adjacent divided by the hypotenuse. The adjacent to this angle is that vertical. So the adjacent divided by the hypotenuse. So you see they actually turn out to be the same thing. All right, let's go ahead and verify it in the calculator just to see that it does work. What we'll do is take the sine of an acute angle. Let's go with 15 degrees. All right, take the sine of an acute angle and evaluate it. If I take the cosine of the complement of that, so that's 90 minus 15, you could do the math, but I'll just show it as it's written here. You get exactly the same thing, okay? All right, and that's why these are called cofunctions here. Why we have the sine and we have the cosine. So those names, remember this is sine and this is the cosine. It's because of that relationship that if you take the complement of the angle that went into sine, it's the same thing when placed into cosine. That's what you get. All right, now we can do the exact same thing backwards, right? We could say that the cosine of theta would be equal to the sine of 90 minus theta. It's the same concept, just a different kind of perspective of it. All right, and then we can do the same thing with the reciprocals of these guys. We can take the cosecant of theta and say that that would be equal to the secant of 90 minus theta. Okay, and then we could also write that the secant of theta is equal to the cosecant of 90 minus theta. All right, and last, the tangent of theta would be equal to the cotangent of 90 minus theta. And last, cotangent theta would be equal to tangent of 90 minus theta. Next, what I want to do is take you through my 5 steps to simplifying trigonometric expressions. Step 1, check for any identities. So you're looking for any identities that are right off the bat. Step 2, convert everything that you can into sine and cosine. There should be a way to do all of that. Step 3, a little bit vague, but do the math. Do we have to multiply things? Do we need to divide things? Does that lead us to canceling different things out? There's a lot of stuff that goes into that, but generally think about the basic mechanics of math. Step 4, check for identities again. Sometimes those become present after you do the math. You might not see them at the beginning, but they show up a little bit later. Step 5, go ahead and simplify anything that you have left over. Usually at that point, there's not much to do. All right, for example number 1, we're asked to simplify cosine x times cotangent of 90 minus x. All right, step 1, check for any identities that might be there. Well, this is an identity. This is one of our cofunction relationships that we have here. So we don't need to have 90 minus x, which we should definitely change because this is just simply x. We don't need to have the 90 minus x. What we can do is change that out for its cofunction. Call it tangent x, okay? Call it tangent x, and then you don't have to have that. All right, so that'll get multiplied by the cosine of x. So that would be step one, look for any identities that might be there. Step two, convert everything into sine and cosine. Check. All right, tangent we can change. All right, we can change that into a fraction, which will be the sine of x divided by the cosine of x. Okay, so I have this cosine x multiplied by a fraction. What I'll do next is go ahead and just place that over 1 so I can see both as fractions and do the math. If I multiply these two fractions and notice that the numerator here is the same thing as the denominator there, these will cancel with each other. They'll cancel, we'll be left with sine x over 1, which is sine x. For example number 2, I'm going to go through my 5 steps and see what we can come up with here. Step 1 is to check for any identities that we have here. All right, this one does not have any apparent identities. Does not have the Pythagorean identity. We don't have any negative thetas. We don't have any cofunction relationship, which means that we can skip over that step and go on to number 2, which is to convert everything into sine and cosine. All right, so secant is the reciprocal to cosine, so we can write that one as 1 over cosine theta. We're going to subtract. The sine of theta is just sine of theta. We don't need to change that one, but you're going to notice that it's going to get multiplied by tangent theta. So I'm going to go ahead and place that in a fraction by just placing it over 1. All right, next to that, the tangent is the sine of theta divided by the cosine of theta. All right, so that is step 2. Change everything in terms of sine and cosine. Step 3, we're going to do math. We're going to see what math we can come up with here. Within these two fractions, we don't have anything that cancels right now. We don't see anything happening there. All right, so we're going to go ahead and just multiply them together. But when we do multiply these together, you're going to get a 1 times cosine theta. That will end up being the same denominator that we have over here. So we can actually build one big fraction with cosine theta on the bottom. You're going to have that 1 minus sine theta times sine theta, which we'll write as sine squared theta. Okay, so it's simplified down to here so far. All right, now from this point, step 4, we're going to check for any other identities that might show up. In the top part of this is actually based off of our Pythagorean identity, which had said the sine squared theta plus cosine squared theta is equal to 1. Now, how does that actually relate to this? If we take the sine squared theta and we move it to the other side, we'll get cosine squared theta is equal to 1 minus sine squared theta. And this is what we have here. So that means that we can substitute cosine squared theta into the numerator here. That'll give us cosine squared theta over cosine theta. Of course, that means cosine theta times cosine theta. So we can reduce, just go ahead and take one of those cosine thetas out of the top, cancel with the one that's on the bottom. That gives us just cosine theta. Example 3 is going to be a little bit different because we already know what we want this to simplify down to. We want it to be cosecant squared A. Okay, so we're not just strictly simplifying, but we're going to simplify down until we get to that expression. All right, so step number 1, we check for identities. Okay, right here, this is actually one of our identities. Okay, that was one of our Pythagorean identities, which said that 1 plus tangent squared theta, we're using A here, but it was theta in our general setup. 1 plus tangent squared theta is equal to secant squared theta. So that means that this set of parentheses, which is this, can be replaced with secant squared theta. All right, so we'll have cotangent A multiplied by secant squared A, it's going to be A, divided by tangent A. All right, so that was step 1, looking for identities. Step 2, let's convert everything into sine and cosine. Cotangent is actually equal to cosine over sine, so that'll give us cosine A over sine A. All right, and then next to that, we've got secant squared A. Well, the reciprocal of secant is cosine. Okay, so this will be equal to 1 over cosine, but you're also going to have that squared. So we're going to have 1 over cosine A. And what I'm going to go ahead and do is just write that twice instead of leaving it as a squared. No, you know what? I actually am. I'm going to go ahead and just write it as a squared and see if that'll work out. So we got cosine squared A. So you can see that as a true reciprocal. All right, and then let's see, on the bottom here, big fraction bar there, we're going to get tangent, which is sine A divided by cosine A. All right, but if we have a complex fraction, if we got fractions being divided by fractions, we can take that bottom fraction and actually multiply by the reciprocal. Okay, so I can take this out and just multiply by the reciprocal, cosine A over sine A. All right, and then that way I've just got 3 fractions that are all lined up. And this does work out pretty good here. Cosine squared A, that means that you have 2 of those. Well, you've got a cosine A up here. You also have a cosine A right there. So these, both of those, can cancel with that one. We end up with 1 over sine A sine A. That would be sine squared A, which, as a reciprocal, we can change it to cosecant squared A, which is exactly what we want.
Later, blah.